Hi everyone, and welcome to the first of two videos going through some past exam questions on bond enthalpies. In this question, we've got a reaction here, and it wants us to calculate the enthalpy change of combustion of ethine. So this is ethine here, so this is the enthalpy of combustion because we're burning it in oxygen to make carbon dioxide and water. We need to calculate the enthalpy change of combustion for that reaction using the bond enthalpies they've given us here. The nice thing about this question is they've drawn the molecules out, so we can see all of the bonds, and that's something that I would recommend that you do if they haven't already done that for you, but here it's already there. So we're going to add up all of the bonds on the left hand side, and we're going to add up all of the bonds on the right hand side. We're going to do them separately. So here we've got a CH bond twice, and what I'm going to do is just tick these off. So we've done that one and we've done that one. So we've got 415 times 2. We've got the CC triple bond is 837, and then we've got the OO bond, which is 498, which is this one, and we need to times that by 2.5. And if we're going to add all that up, those are all the bonds that we're going to have to break. Okay, so let's work this out. 415 times 2 plus 837 plus 498 times 2.5. So 2912. And those are all the bonds we have to break. Breaking bonds is an endothermic process. We have to put energy in order to break a bond. So we're going to have to add that much energy to break all of those bonds. Okay, what about the bonds that are being formed? Well, we've got the OH bond, which is this 464. And we've got that twice. And then we've got the CO double bond, which is 805. And we've got that twice, but then we need to times that by 2 as well because we've got 2 CO2 molecules. So we've got in total 4 CO bonds. And then we've done that as well. And then it's just, yeah, we haven't missed any bonds here. We've ticked everything off. Okay. So we need to add this up. 64 times 2 plus 805 times 4. Is 4148. And these are the bonds that are being formed in the products. Now, forming bonds is an exothermic process. It releases energy. So we're going to get that much energy given out. Okay. And now to calculate the actual enthalpy change, we're just going to do what it says here. We're going to do plus 2912 minus 4148. 2912 minus 4148 is minus 1236. Okay. Does that make sense? It's enthalpy of combustion. So combustion is definitely an exothermic process, isn't it? So the fact that we've got a negative answer is a good thing. If we'd got a positive answer there, we'd be thinking we'd done it wrong, right? Because enthalpy change of combustion should be negative. Okay. The next question we've got here is a similar sort of one, but it's slightly different because instead of being asked to calculate the enthalpy change of reaction, it's saying calculate the bond enthalpy for the HI bond. Okay, you can see they've already given us delta H here. Okay. So this is going to be slightly different. So again, we're going to do the same thing though. So we're going to add up the bonds that we need to break. Okay, so we need to break the hydrogen bond and we need to break the iodine bond. So we're just going to add these two up. 436 plus 151 okay, is going to be, we'll probably work that out, so it's going to be 587 plus 587, okay, because we need to add both of those together. Okay, those are bonds we have to break, so we're going to have to put energy in to do that. And then what we're going to do is we want to work out the HI bond, so we would then have to take away 2 lots of the HI bond, okay, because that would be a negative value because those are bonds being formed, so that'd be exothermic. So 587 to break those minus the 2 HI bonds is going to be equal to minus 9. Okay, and so now we just need to rearrange this. So if we add 9 here, and we're going to take the HI the other side, so 587 plus 9 is 596. Okay, we're happy with that. I've added the 2HI to, so that goes here, and then I've added 9, and then we just need to divide by 2. So 596 divided by 2 is 298. Okay. And I'm going to put plus 298 just because bond enthalpies are always positive. They're always written as if you're breaking the bond. They haven't put a plus sign here, so you could get away without this. But I want to get in the habit of always writing a sign whenever we're doing enthalpies. Okay, and the last question for this video, we've got one here. So here's our reaction, and we need to calculate the enthalpy change of reaction here. Now in this one, we can see we've been given the formulas, but they haven't drawn the molecules out for us. So I'm going to do that first, because otherwise we could miss a bond. We need to think about how these things are actually bonded together. So we've got here CH2Cl, CH2Cl. Right, so that's going to be, essentially, it's dichloroethane. Okay, so it's going to be CH2Cl, CH2Cl. And that is turning into CH2CHCl. So that's chloroethene. So that's going to have a double bond. CH2CHCl plus HCl. Okay. So drawing those out, I think, is going to make it clearer which bonds we've got. So then we're going to add up all the bonds we've got on this side. So we've got CH bonds, which is 413. And we've got 1 there, 2, 3, 4 CH bonds. So 413 times 4. Then we've got the CC bond, which is 347. And then we've got CCl bonds twice, so it's 346 times 2. Okay. So let's add up all of that. 413 times 4 plus 347 plus 346 times 2. That's 2691. And that's going to be a positive number because those are all the bonds we have to break. We have to put energy in to break those. Okay. So that's going to be this side. And then if we add up all the bonds here, we've got CH bonds again. So we've got the 413 times 3. We've got the CC double bond, which is 612. And I've got carbon chlorine bond, which is 346. And I've got the hydrogen chlorine bond, which is 432. So all of that lot together is 413 times 3 plus 612 plus 346 plus 432. And this is 2629. And that's going to be a negative number because these are all the bonds being formed. That's going to release energy. So now we just need to use these two numbers to do the calculation. So plus 2691 minus 2629. It's going to be a pretty small number, isn't it? 2691 take away 2629, 62. So it's plus 62. Okay, and here we said with this one, didn't we, that I put a plus on it. We didn't really need the plus. It's a bond enthalpy. Bond enthalpies are always written as positives, but you don't usually put the plus. This one, I think it's a very good idea to put the plus on because this is an enthalpy change, and this could be minus 62. Okay, this was never going to be minus 298 because bond enthalpies are always positive. But this could be minus 62, and I just think it's clearer. Right, let's show it's definitely positive.